Good afternoon, everyone. Hope you're all doing great. Thanks for coming for this talk. Let's begin. As Terry said, I'm Anurag Sharma. I'm the Director of Quality and DevOps. I work for the Software Solutions team for the Honeywell Home and Building Technologies group. Honeywell Home and Building Technologies is approximately a $10 billion revenue group. And what we do as part of this group is we build devices, connected devices for home and buildings, right? It's all part of the IoT revolution, right? Honeywell is a 100-plus-year-old company. We have devices all around your homes and buildings. And now we are in the next phase where the company is now on a trend to be converted to the digital mode, right? The goal is to connect all these devices to internet, to your mobile app, so that you can now control them remotely from anywhere, right? In addition to that, the next big thing we're trying to do is make all these devices smarter, right? It's not just enough to connect so that you can control it from your mobile app, but make them smarter so that they do the right things themselves, right? They understand what the user wants. They study the user pattern, and they do the right thing. It's along the trends of home automation and building automation, right? That's what. So my team is responsible for the software that goes into it, and I own the quality and DevOps part. I started my career 18 years ago as a software developer, and slowly moved up the chain and moved into quality. One of the rare transitions, moving from development to quality. I did that, and I'm glad I did that. And here I am now, right? The topic is, are manual testers needed in this automated DevOps world? It's a pretty contentious topic. I think everybody has an opinion on that. I'm going to give you my opinion. So let's carry on. All right. So before we move ahead, I think all the presentations we've seen so far is about a mobile app or a web app or a web application, right, running on the browser. IoT, things are a bit different. Your system is more involved because you have a real hardware in the loop, right? So this is one of the more simpler system that we have, which is a thermostat, right? It's a smart thermostat. It's a Wi-Fi connected thermostat. These are a couple of our newer offerings. And this one you see is a water leak detector, right, as well as a freeze detector, right? So these devices are used in typical homes, right? And what you see is, as part of the system, there are these hardware devices, and they have firmware in them. They have embedded software residing in them. A lot of logic and the domain-specific information is built into these devices. These devices are talking to the cloud. We have our web services living in the cloud. A lot of business logic lives in the cloud. There are multiple layers of the cloud. You don't have to worry too much about these acronyms, but basically there's a cloud component, right? In the cloud, you have the databases. You have a big analytics engine that's collecting a huge amount of data from your devices and crunching it and providing valuable insights to the user, right? And finally, you have a mobile app. And this mobile app gives the user access to your devices so that you can now control your devices remotely through the mobile app, as well as it has a lot of other smart automation built into place, right? All these subcomponents, I'm going to refer to them as 3 different subcomponents, are all talking to each other, right? So this is what a typical IoT system for a thermostat looks like, right? One more thing that makes life a little bit more difficult is the scale. We sell hundreds of thousands of these thermostats, and that's a pretty conservative number, right? So when we build our web services, right, we have to support hundreds and thousands of instances of the APIs and web services being used, right? That's a big number, right? So scale comes into play. And thirdly, this is pretty important, right? If your thermostat fails in the middle of a New England winter where I'm from, customers are not going to like it, right? So it is pretty important, right? And this is a thermostat, right? Our applications are not just thermostats for comfort, but security, fire, and those kind of applications, right? So this is what a typical system looks like, right? Now, just to collect our thoughts, we've been here for 1.5 days. We all know DevOps is key, automation is key, and automated CI/CD pipeline is really important, and tests have to be integrated as part of that. So what we had in Honeywell, so I joined Honeywell around 3 years ago, right? Before that, most of the testing was primarily manual, right? And as you can imagine, things were slow. It took us months, sometimes years, to push out a new product in the market, right? Once a product is out, to maintain it, to fix defects, to push out new features was a nightmare. Our releases were once every 6 months, and who would buy that, right? Not enough, right? And over time, our products continue to become more and more complex, right? Remember I said these products have to be smart, right? So people need more features. A lot of competition out there. Everybody is getting into IoT space, right? So it became more and more difficult to manage all of these different products, right? And the typical triangle of getting great quality out, getting features out sooner, and getting more and more features out, right? Really difficult. So, in the last 3 years, we've made the transition. The executives realized that, yes, we have to transition to automation. And, we are making a rapid shift towards test automation. Buy, borrow, build. We are buying tools, Sauce Labs. We've been using Sauce Labs for almost 2 years now. We are borrowing resources, contracting, outsourcing to convert our manual tests into automated tests, and building our own internal teams, hiring good STATs, hiring test automation architects to build our own frameworks and infrastructure. So over time, we have converted a lot of our integration and system level manual test cases into automated test cases. Different teams are going at different paces, but clearly this is the mantra that we are going to automate more and more, right? In my talk today, I'm going to be talking primarily about the system level test cases. In our company, unit test case automation is a developer's responsibility, and system test case automation is for the quality team, right? So we're going to focus more on that. And we were not any good from unit test point of view, right? Either. Most of our code 3 years ago did not have any unit tests, right? It was all manual, right? A waterfall kind of SDLC, right? Of course, in addition to improving our test scripts and automating more and more, we went through process changes. We've adopted CI/CD, automated CI/CD, right? We do testing as part of CI/CD. There's continuous testing in place. Fail early, fail often. Use behavior-driven development for system test cases, and test-driven development for unit testing. And test automation essentially is now part of definition of done. You are not done till you have automated, right? Great to see that test code is now a first-class citizen, right? It is not an optional thing. It cannot be deferred. Your user story or your epic is not done till you've added the appropriate amount of test automation. So all great things, right? So that begs the question, right? What are manual testers going to do, right? Honeywell, a typical industrial company, we have hundreds of manual testers, right? And there's a lot of anxiety among them as to what their future is. Will they have a job, right? How are they going to survive in this wave of automation, right? And this wave is only going to get stronger and stronger, right? This is a mega trend, there's no denying that, right? So clearly, we need those manual testers, right? Those manual testers have this huge domain knowledge, right? And in these systems, comfort, security, fire, that domain knowledge is equally important. We can't let go of that, right? Over the rest of my talk, I'm going to talk about all the different ways these manual testers can provide value. And ultimately, they have to merge with this test automation trend, right? So I guess the point is, for anybody who thinks or proposes that you can lay off all your manual testers today, I think that's a bit too harsh. We don't have to go with that option because these manual testers can provide a ton of value. So let's go over some of those things. In fact, I would like to say that the testing done by manual testers is more crucial than ever. So hopefully the next few topics will help clarify that. The first thing, more edge case and exploratory testing. Better understand user environment and gracefully error out. We know this, right? We are supposed to do this. Everybody knows that. But the reality of the situation was all along, these manual testers were just so busy in doing the happy flow and the top feature and the most important thing testing, they never had time for all of this, right? They never got around to doing justice to this edge case and exploratory testing, right? If you remember the diagram that I showed you a little bit earlier of our system test, right? Notice that your devices are sitting at your home, right? They are on a separate Wi-Fi network. Your mobile is on a separate network. You are driving somewhere, right? Then you have a third network and a third infrastructure of your where your cloud services are residing, right? 3 different configurations, and all these 3 have to be optimal or meet a certain requirement for your overall system to work, right? That doesn't happen always. As the number of connected devices are increasing in every home, you might not have enough bandwidth for each of your device. Obviously, with all the streaming devices and everybody in the home having multiple Wi-Fi devices, there's a more and more contention of getting enough bandwidth for all of your Wi-Fi devices, right? So the point is, are we doing enough testing, right, of throttling the network at each and every end and seeing if the system still behaves, right? And if it does not behave, how are we erroring out, right? I've seen that half the times we give a much better user experience by having a more graceful, a more understandable error message for the user, giving him some hints as to how he can recover from that, right? We realized we didn't do any of that. Our error messages were cryptic. Oftentimes, they were a security breach. We were giving too much information out in the error messages. So this is big, right? One irony is when our testers test something in an ideal lab environment, everything works for them. But then when we get user reviews, we get reviews that, hey, this exact same scenario does not work from them, and we get a poor rating. It's primarily because of these things. We did not try out our product in all possible scenarios, right? Unfortunately, if things don't work, you're bound to get a negative review. But if things work, you will not get a positive review. That's how it's supposed to work, right? So when your product works 9 times out of 10, you'll end up getting a review of 2 out of 5 or something on App Store, right? That's the reality. So this is really important, right? I'm going to quickly tell you, so these are all the different kinds of testing that were important, but always took a backseat, right? Destructive testing, visual testing, usability testing. These manual testers who know the product, who know the domain, who know the users, who better than them to serve as usability testers, right? But they always thought that their goal is to just be part of that user story and that's it, do whatever was given. They can play a big role now in putting a different hat of a user and providing usability testing. Beta testing, right? So when we have a new product launch, when we introduce a new product, a new thermostat, a new camera, whatever in the market, we do beta testing, right? Again, we've often seen that as part of beta testing, we get really good ratings, right? 4.5 out of 5, right? But when the product hits the market, ratings are sometimes not that great. Why? Because again, sometimes our beta cycles aren't long enough. Our beta testers don't spend enough time, right? So these manual testers have a great opportunity to see whether we got full coverage as part of beta testing or not. If not, these manual testers need to help out our beta testers by providing them these different scenarios that they probably forgot or did not test. Maybe they were in a hurry or whatever, right? So get more effective beta testing in place, right? Performance and stress testing, right? Again, always took a back seat, always push towards the end, right? They can help manage these testing better. Security testing, a whole topic in itself. What we've done in Honeywell is we've created a lot of courses with regards to security testing, all the way from security in development, security in design, how do you do security testing, some of the basic things. And we are helping our manual testers to become better at the security testing, right? Compatibility testing. You saw that there were 3 different software components. You've got the firmware or the embedded software, you've got the cloud piece, you've got the mobile app piece. All these 3 are separate teams and they all release independently. When one software releases, you have to make sure that that version is compatible with the existing versions of the other two subcomponents, as well as the in-development versions of those other components, right? It has to be compatible, cross-compatible with each other. And I'm going to be talking about compatibility with regards to mobile apps in a little bit. So all these testing, which we all know needs to be done, right? But somehow, because these manual testers were just too busy testing the happy flow and those more important features, they never found time for that. Well, all of that is now automated, right? The most important use cases are automated. You're not spending time on those. So go ahead and do this, right? And this will actually take your ratings from 2 or 3 to a 4.5 or 5-star rating, with these things. So that's one part. Now I'm going to spend some time talking about mobile app testing challenges. We just heard from Asaf. He talked about some of these mobile app testing challenges. But mobile app testing is hard, right? It has a lot of challenges, and this is number one, right? You've got so many different combinations of device manufacturers, form factors, operating systems, network conditions I talked about before, whatnot, right? How do you ensure that the app that you've made works with all possible combinations, right? How do you make sure that you've tested for an iPhone 6 Plus with OS 8, 9, 10, 10.2, 10.3? It's pretty much impossible. And then you go to Android, and the matrix is even worse, right? Can't scale. It's literally impossible. You can't test everything, right? Huge challenge, right? And then comes your reviews, right? As I just alluded to before, it doesn't take a lot for your rating to drop. Even though the product is working perfectly for 90-95% of the users, you can still be at a rating of 3 or 3.5, right? Which is not good, right? We strive, and I'm sure all companies strive to at least have a rating of 4 and above, right? So that's a challenge. Another challenge with that is people use these ratings to buy. So these ratings are really important, right? One person has a bad review, he puts it down there, the whole world knows about it. That wasn't the case with our browsers before, right? So it's hard to hide anything that might not have worked. And thirdly, and this is especially a problem with Apple Store, that when we get a review from a user, we have no way to identify what is that username for our product. They don't give you that information. So we can't really tie a user review with our internal system and see, okay, what user was that, right? And try to dig up his log. So debugging is hard. 99% of the times, the response I get from my quality teams is, hey, this works, but obviously the user is not lying, right? So that's a huge problem, debugging the problem, right, that a user is talking about. And then even if you found out the problem, your DevOps principles don't really apply. You can't deploy immediately, right? You have to submit it to the App Store. Apple takes 4 to 6 days. There are holidays in between. They don't, they actually December 16th, they close down. They don't accept new apps, whatnot, right? It's very hard to deploy fast. So that means if you release a defect, that stays out there for a week, and you know how much damage a week's time can cost your app, right? And then this is a delay in the App Store, right? Continuous delivery is not possible. So with these challenges, I think the role of manual testers is greatly amplified. And how can they help us better manage these challenges with mobile app testing, right? So this is pretty important. So even though you have your automated tests, right, at a unit level, system level, right? But where are you running those tests on, right? What is your combination? We just said that it is practically impossible for you to run your tests in every single combination. It's practically impossible. I mean, we saw a demo, it was a simple little test, one test, they ran it on a few combinations. But when you have thousands of unit tests and hundreds of system tests that are running more often as part of CI/CD, right, you can't really do that. So what do you do, right? What we've done is we've split our mobile devices into 3 categories based on our user feedback, right? So there is a tier 1, and 60% of users use the combination that is in the tier 1 devices and operating system. Then we have tier 2, which is the next 20%, and tier 3, which is the least common 20%, right? So what we do is we have to strategically run our tests in the tier 1 because that's where 60% of the users are in that particular combination. But every once in a while, loop through tier 2, tier 3 devices and those combinations, right? Somehow we have to find a way to get coverage across all devices, right? So that, so we've got test object, or whatever cloud you're working with, you have to keep tweaking that combination on pretty much a daily basis, right? Within a week's time, we release every 2 weeks. So within that time, you have to make sure that you've gone through that combination and minimize the risk over there, right? And again, as part of that, you strike balance between simulator, emulator, and real mobile device. Ideally, we would like to test everything on a real mobile device, right? There are certain features that we can't even test on a simulator, emulator. But again, cost comes into play. We want to test more and more, limited, keep the testing cheap as well. So strike a balance over here, right? And then again, keep moving things, right? If you've run a test on simulator, for like 20 times, maybe you want to then move it to a real device and run it a couple of times and then move it. So you're constantly juggling where your automated tests run, right? And then this is a killer, right? You've got new versions of operating systems coming all the time, right? We want to be the first ones to be testing our product against the new version. There's a new iOS version coming out soon, right? Android, there are new versions coming out. Are we making sure that we are proactively testing against these new versions? And then it's not just OS, it's all these third-party SDKs that we use, right? Are we testing against the newer version of those SDKs, right? So all of this is not easy task by any way. Then obviously visual testing, right? How can we automate more and more of the visual testing? So these are a few things that manual tester can really help without knowing any programming, but these things are really important for us to manage, right? Now, along those same lines, he can be more involved with the test automation, and here are a few ways, right? We made our manual testers as the reviewers of all the automated tests. So every time somebody has written a system-level automated test, we make the manual tester who had been manually testing that particular test task all along to see whether the test makes sense. Did they include all the various test points that they were supposed to have included, right? So make sure that the automated tests are indeed doing the right things and they're indeed relevant. Backlog, right? We are catching up in this game of automation. Prioritize backlog. This is huge, right? They understand the domain. They understand they read the reviews every day. They see what the customers want. So help prioritize that and make sure the important stuff gets done sooner. Now this is pretty important. Let me spend a minute on this. So what this means is, you saw that our system has 3 big components, and for the thermostat application. Oftentimes, when a defect comes in, it's not obvious where the defect is. Is it in the mobile app? Is it in the cloud? Or is it in the firmware? It's not clear, right? Unfortunately, a lot of people are pointing at each other. The app guy says, hey, I'm just a display thing. It has to be you. And it's not easy, right? Ultimately, we have this role called systems engineer in our company, and he or she is supposed to look at what the problem is by inspecting all the logs at each component, correlating them, and figuring that out. But there are very few, right? The number of defects coming in a lot more, and the system engineer is not enough. So they become the bottleneck. Manual testers, we've been training them to actually serve the role of a system engineer so that they now have access to the logs of each component, and they can go through the communication and the messages going across this and see where the problem is, right? There was some training involved, but a lot of them enjoy this. They are now able to assist the system engineers in debugging the problem and helping us understand where the problem is. Half the battle is won, right? In our case, as I said, debugging it was taking the longest amount of time. Once that is done, we are quickly able to resolve it. So this is big, where they are now serving as systems engineer, and they now have they're not just black box testers, right? They understand what's happening under the hood, what's the timing diagram and whatnot, right? And obviously work with DevOps team to build the automated CD pipeline, make sure tests are running, make sure things are happening as per the requirements over there, right? And then finally, in this topic, they can be directly involved with test automation ecosystem, again, without learning how to code, right? Some of these things are analyze automated test failures, right? We just saw that tests, we have huge number of tests, they're running as part of CI/CD. Obviously, when you run so many tests, and a lot of them are system-level tests, and we do understand that system-level tests are a bit brittle, right? There are some false positives in there. So help analyze the test failures. And this is a daily activity. This is a daily grind that somebody has to do, right? Otherwise, there's no point in doing all the automation. So this is a very important activity, and they can help us identify whether it's a product issue, whether it's a test environment issue, a sporadic issue, or a script issue, right? This piece of information has to be analyzed on a daily basis. If you don't do it, you've fallen into the trap again. You might as well have not automated anything, right? So they help with this. And then not only are they doing this daily exercise, they are also training developers, product owners, and everybody to be able to analyze test results, right? Obviously, when they're looking at test results, they can reach out to the testers, the STETs who build those tests and say, hey, look, there's not enough logging in there, right? Improve the logging so that it's easier to understand what went wrong. So huge opportunity here, right? At the end of the day, we do not want the STET who developed the test to be looking at it, right? We want the whole team. Quality is everybody's business, right? The whole team to be helping out with this. Increased test automation coverage. It kind of resembles what we talked before, right? Help prioritize the backlog, right? Make sure that all the important scenarios are covered. Whenever there's a defect leaked, right? Are they doing an RCA and helping us identify what test was not automated, so that next time we've locked the behavior down by an automated test, right? And then finally, test the automated test, right? Identify false positive and sporadic test failures. The biggest challenge with test automation is this, right? False positive and sporadic test failures. It doesn't take long for this number to rise and people losing faith in your automated tests. So this, again, has to be constantly be reviewed so that we never get this number above a certain percentage, right? In our team, we cannot have more than 5% false positives and test failures for a system level test, right? The unit tests should be a lot more stable, right? And help us gather trends and help resolve, right? Thankfully, all these Sauce Lab analytics and everything are a great blessing for us with which we can further narrow down on these things, right? Eliminate unwanted latencies in tests. Help optimize test case organization, combine and split test cases. Now, this is big, right? You're testing a certain feature. You might as well add one more little check on that, rather than creating a new test just for that little thing, because you've added that check in the previous test. It doesn't really add much to the test time, and it's a lot more efficient that way, rather than creating a whole new test. And note that every system level test has its overhead, right? You have to install the app on the device. You have to log in, right? You have to, and then you have to go to the right page, and then you start that test, and then you have to log out and everything as part of cleanup and destroy the app, right? All those things can be eliminated. So this is all about efficiency, right? Combining the right tests. And similarly, we don't want long-running tests, right? Because that would be your biggest pole as part of parallelization, right? So help split the long-running test. And when you split it, you can either create a new test or combine with an existing test that's almost doing the same thing. So a lot of judgment needed over there. And ensure maximum parallelism, right? Now, in a lot of the talks we heard, the parallelism was only at the mobile app or the application side, right? Your web browser mobile app. In our case, we want to parallelize over there so that the application is running on hundreds of devices, but then the application talks to a device, right? A thermostat or whatever. So we need to have similar parallelism over there because there's a one-to-one connection, right? So that's the test bed that we maintain internally of all our Honeywell devices, right? And we got to make sure that when we are trying to increase parallelism, we have to do it at both ends to really get the true parallelism. So this test bed maintenance of all of our devices is a big task. Make sure all those devices are up and running. They're connected to the Wi-Fi, right? And we don't see any issues due to them. And then this one is, again, very important, source code to test case mapping. So what do I mean by this? We want our system test to be part of CI/CD, right? But it's not practical for us to run every single test as part of every single build. There are dozens of builds in a given team every day, and we have hundreds of tests. Our system test takes 2 hours, even after we have highly parallelized it, right? Because these tests take long to run. And oftentimes, it doesn't make sense to run all the tests because the developer might have changed the code in a feature, let's say feature 1. You ideally only want to run your smoke test and your feature 1 test. You don't want to run all the other tests because they are probably not relevant in this case. So this is what we've done. We have tried to map a source code module and tagged our tests accordingly so that we are running the minimal right set of tests that make sense, right? So this way, we are able to do more smart testing, run the tests that really matter, get more coverage, and still be efficient, right? So they can help with this mapping that that I just talked about. And finally, they can help with creation of test scripts. Now, this is where the problem is. In my interactions, a lot of the manual testers I talk to, they just have this mental block that, oh, coding is hard. I can't do coding, right? They just fear coding, right? But they don't realize that it's actually pretty simple, right? If you have done a proper architecture, you're using page objects and you're using action-based testing where you've created appropriate modules that do all the hard work, all that is left for them to do is just combine these keywords that we call in the right logical manner, right? Because all the work of getting the element, clicking on them, checking everything, a lot of that is taken care by the module. So it's a very gradual and slow transition, right, for them into programming world. And then on top of that, we're using Gherkin. We're using feature files. So it's not even coding then. You're pretty much writing English sentences, right? Gherkin, if you've wrote about it, it's like when blah, blah, blah happens, then do this, right? It is actually very simple. So we really have to encourage them to get out of that mold, break that fear of testing, of coding, and get into this world. It's not that hard, right? And then eventually, of course, they can help. They can also help create specs for all these keywords and help them evolve. And then this is what I was talking about. Ensure test logs are readable and verbose for quick debugging. Because, again, what's the point of running automated tests if you can't quickly figure out what went wrong, right? You want to be able to quickly identify your problem. And then finally, measure test automation effectiveness, right? These are all kind of analytics, right? What's going on? What's the health of your product? What's the health of your tests? And so on and so forth, right? Overall, try to reduce the overall test cycle time, see where the latencies are coming from, where the bottlenecks are, right? So with that said, right, my conclusion is we need these manual testers, right? They can do so much what we talked about, right? We need a combination of both manual and automated testing, right? Over time, these manual testers, like anybody, like any professional, they have to evolve. They have to learn about, in this case, manual testers have to learn about programming, right? But it's a very slow transition. They've got a lot of runway. And if they plan their careers well, I think they can definitely succeed. The nirvana for us is there is no manual tester, there is no automation tester. There's just one engineer who does everything, who understands the domain, who understands how to automate it, and who's able to do all those other kinds of testing and all those other kind of tasks that are really important. That's all. Thank you.